Ah, welcome. I know that I said today I was planning on having a quiz, but I was mistaken when I was looking at the calendar. I completely forgot that seniors are done at the end of May, whereas everyone else goes into June. And since seniors are done at the end of May, that means you only have, including this, 4 assignment cycles left. 4 assignments left in each class. So I figured I'll just change it up. I'll make the quiz the last test of the year on all the energy stuff that we've been doing, and I'll put that off until the last day, which is the week of Memorial Day, the Tuesday, Wednesday, Thursday, last week of May. So essentially we have this assignment, we have all next week, and then we have one assignment the week of Memorial Day, and that's it. That's all we wrote for senior year. Done. So what I want to do today then is get into what I was going to do after the quiz. So we're doing the same things, just rearranging it. And what we're doing today is talking about energy and kinematics. So we have been talking a lot about energy, potential energy, kinetic energy, energy transfer, and I want to be very, very clear. Everything that we've done this year connects. Everything relates to each other. So we started the year studying something called kinematics. And if you don't remember the kinematics or the kinematic equations, that was like the V naught, little Susie standing at the edge of a cliff dropping a ball. So I figured, hey, let's look at this picture. We have a guy jumping off a cliff, and as he's falling, he's transferring his potential energy, the potential energy he had from climbing up the cliff. It took him energy to climb up the cliff, and he's releasing that energy by falling into the water. So as he goes down, he loses PE, gains KE. In the very beginning of the year, though, we talked about dropping things off of cliffs. So when little Susie was standing on the edge of a cliff and she dropped a ball, did it lose potential energy and gain kinetic energy as we were doing the TVD charts? Let's see. We know that an object falls to the ground, it transfers potential energy into kinetic energy. It loses height, gains velocity. I hope you guys get that by now. We spent a lot of time really focusing on this, but this is what we really need to make sure we understand. TVD chart, where we started in the very beginning of the year, when she would drop the ball, and I would say, well, how fast was it going after 1 second? How far did it go after 1 second? And we would fill in chart after chart after chart. I want to quickly review how to do that because that's coming back. Well, remember, free fall means your initial velocity is 0. Free fall means you simply just hold it and it drops, and this ball is just going to fall down. So that means her starting velocity is 0, and her displacement is 0 at first because it's still in her hand. She drops it. What pulls it down? Gravity. Gravity pulls it down. So if it's been falling for 1 second, its velocity is now going to be -10 because gravity is -10. After 2 seconds, -20. -30, -40. Hopefully we remember this, but if not, we're like, okay, we're just adding the gravity every single time. Gravity, we know, is -10. We're just doing -10 times the time that it's been in the air. So -10 times 1, -10 times 2, simple. To get the displacement for a free fall, we have to use the equation d equals 1/2 AT squared. If those of you who have been particularly astute, this is the exact same format as the KE equation. You have the 1/2, you have the thing that's squared. So we've actually been doing this math all year long, and I just want you to see it's that similar. So d equals 1/2. A is -10. A is the gravity. And we're just going to plug in the time. We're going to do that every single time, every single second. 1/2 of -10 is -5. 1 squared is 1. So the displacement is -5. I know you're going to be like, hey, Bazzuto, we've done this. I know how to do this. This isn't that hard. Okay, that's great. If you don't, though, or if you lost your notes, you never took the notes, you never learned it, this is what it is. We're going to jump ahead to do something else in just a minute. One thing I want to say is when you use this equation, A is always going to be -10. Do not make the velocity. Do not make the velocities your A. So it's always going to be this -5 times t squared. -20. D equals 1/2 -10. 3 squared. Type that in the calculator. -5 times 9. -45. Zero, you're flying through this. That's okay. You can go look at your notes from a long time ago. AT squared, -10, 4 squared, 1/2. Half of -10 is -5. 16, -80. Okay. We have done this chart. You probably have this chart several times in your notes on worksheets you've got back. You have seen this before. This is not new. So what is new? I'm adding things to the chart. Here we go. This is the chart that we've just filled out. We just filled this whole chart out on the other slide. All these numbers. So if you don't know where these numbers came from, look back at the other slide. We still have little Susie sit at the edge of the cliff. But now I'm going to give you a little bit more information. Let's assume that we're dropping a 4-kilogram stone off a 90-meter cliff. How can we do this? How can we fill in all of these blanks at every second? I'm going to walk you through it. You probably actually know. Let's look at time 0. This is a good one to start with. At time 0, the velocity is 0, the displacement 0. What's the height? Well, if it's a 90-meter cliff, the height is 90. That's how high in the air it is. So what's the potential energy there? We cannot forget our equations. PE equals mgh. PE equals mgh. So the mass is 4. Gravity is 10, because with the energy equations, it's always positive. And the height is 90. 4 times 10 times 90. So that's going to be 3,600 joules. All right. What's the kinetic energy? Well, if you start off from rest, if the velocity is 0, then the kinetic energy is 0. So what's the total energy? The total energy is just what you get when you add the PE and the KE. 3,600. Oh, shoot. If we know the total energy, I know that total energy never changes. I know the total energy never changes. So there are many, many ways you can solve this problem. Well, I know that the potential energy is going to be going down and the kinetic energy is going to be going up. I know that PE plus KE for this problem will always equal 3,600. So there are a couple of ways you can do this. You can look at the velocities and you can calculate the KEs. And if you calculate the KEs, you can subtract to get the PEs. And once you have the PEs, you can solve for the height. That is a legit way of doing it. That's not the way I'm going to do it right now, but there would be nothing wrong with doing it that way. This is how I'm going to do it. If we had a height of 90 and you fell 5 meters, What's your height? 85. 90 minus 5. Okay. If you had a height of 90 and then you fell 20 meters, what's your height? 70. Now here's what I'm trying to show you. You are starting off at 90. The definition of displacement. The definition of displacement is the difference from where you start to where you end. So this -5 is from 90. The -20 is from 90. Don't do 85 minus 20. That will not give you the height because displacement is from starting to ending. Okay, this is not so bad. So let me go ahead and calculate the potential energy here for 1 second. So it is 85 times 4 times 10. So the potential energy is 3,400 mass times gravity times height. So if this is 3,400, I know I have to add up to 3,600. This has got to be 200. Nice. So far, so good. PE is going down, KE is going up. Let's look at the next spot. Let's do 70, which is now the height, times 4 times 10. This is now 2,800. That means the kinetic energy has got to be 2,800 plus what is 3,600? 800. So many ways of doing this. I could keep going. I could do 90 minus 45 and get the height here. But what I want to do is I want to show you that there's other ways of figuring it out. Let's look at the velocity. We know that KE equals 1/2 mv squared. So the kinetic energy is going to be 1/2 times 4 times negative 30 squared. Now, when you square a negative, it becomes positive. So I don't care what your calculator says. Make sure that when you square a negative, it becomes positive. You might need to use your parentheses. So we just got a kinetic energy of 1,800. Okay, that's consistent. So if this is 1,800, what is the potential energy? 1,800. Oh, that's interesting. They're the same. Oh, that makes sense. 45 is halfway down from 90. Oh, so when you're halfway down, you have half and half energy. So what's the height here? Yeah, you could do 90 minus 45, or, I just want to show you this, you can do 1,800 equals 4 times 10 times h. I'm just trying to show you the different ways that you can go ahead and solve this. So 1,800 divided by 40 is going to be 45. There are just so many ways of solving this. You have so many ways to go. I want you to see how all this connects. And I could have taught you the potential and kinetic energy back in November, but I didn't because I wanted you to go through and understand how to do it with velocity and displacement first. And now we're seeing how all this connects to these charts here. So we have 4 seconds, okay? It fell 80 meters, so that means we have a height of 10 meters. Your height, if your height is negative, that means you're below where you started. So like, let's say as if you're dropping it. Like, you're underground, essentially. So that doesn't really make sense. Height is how high you are above ground. So height should never be negative. Displacement can be negative. Displacement means below where you dropped it, but height is never going to be negative. So if the potential energy, 10 times 4 is going to be 400. And then the kinetic energy has got to be the difference. Look at that. Everything connects. There's so much meaning here with these numbers. And it all works out. And then I can use these to solve for these if I didn't know them. What do you mean if I didn't know them? When would I not know them? Vertical throwing. So much good stuff here. So let's go ahead and say that I've given you the information in a different way, and then, oh, sorry, the mass is 2. My fault. Meant to put that in, but I didn't. I'm going to tell you that the mass is 2 kilograms. Can we picture what's happening here? Little Susie's on the edge of a cliff, but instead of dropping the ball down, she throws it up. So it's going to go up, and it's going to come back down. Let's say she catches it. A lot of things you can do here. Check this out. I know that to get the velocity, you just subtract gravity. Gravity is -10. So 20 plus -10 is 10. Minus 10, minus 10, minus 10. Bam. Look at what we just got. We actually have a lot of information now. With this velocity, I can get the kinetic energy. So I'm going to do that right now. Ke equals 1/2 times the mass of 2 times 20 squared. Kinetic energy is 400 joules. I did 1/2 mass v squared. Potential energy is mass, gravity, height. 2 times 10 times 40 is 800. So our total energy here is 1200. So every spot is going to have a total energy of 1200. Nice. I feel like I'm at the whiteboard. My handwriting is terrible. Awesome. So I don't remember how to get the displacement. That's okay. That's okay. To get the displacement vertical thrown, you could use the equation d equals v naught t plus 1/2 at squared. But tell you what, nobody ever liked that equation. I mean, I did, but none of you liked it. Let's not use it. Let's use energy stuff. All right, I don't really see how I can do that, but we'll try. So let's figure this out. So when I have a velocity of 10, what's my kinetic energy? Oh, I can do that. 1/2 times 2 times 10 squared. 100 joules. I'm not going to write out every step anymore because I hope that we're good with the PE and KE equations at this point. We've spent a lot of time on that. I hope we can do that. And if not, office hours exist. So, if the kinetic energy is 100, what's the potential energy? Yes, 1100, because it still has to add up to the same total energy. So if the potential energy is 1100, what's the height? Well, I will show this one. I will show this one. You know what? I'm going to get a better marker. PE equals mgh. Our PE is 1100. Our mass is 2. Our gravity is 10. And we're solving for our height. So it's just 1100 divided by 20. It's just 1100 divided by 20. So our height is 55 meters. Okay? So if the height is 55 meters and displacement is the difference from where you start to where you are, 40 plus what is 55? The displacement is plus 15. Because we went up, because she's throwing the ball up 15 meters. Nice! Take a look at this. Keys, keys, keys. I want to show you something. Keys and patterns. When the velocity is 0, what's the kinetic energy? 0. So what's the potential energy? 1200. Oh my goodness. Interesting. So we know that it's not moving at the top of its path. So what's the height here? So instead of using 1100, we're just going to plug in 1200. And when we do 1200 divided by 20, we're going to get 60. What's the displacement? From 40 to 60 is plus 20 meters. If you don't see how we're getting this, you can still use this equation. That's not ever going to be wrong. But I do want to show you this next thing. I used to say that going up and down in vertical throwing was symmetric. Because the velocities here are 10, right? When you square velocity, whether it's positive or negative, when you square it's going to become positive. So when you do the KE equation, both these velocities become positive. So that's going to be this again. And if this is the kinetic energy, this has to be the potential energy. And if this is the potential energy, we already know the height. We already know the displacement. Sweet. Ooh. And if we are at negative 20, we already know the kinetic energy. We already know the potential energy. So we already know the height. And we already know the displacement. It's back where it started. It is elegantly beautiful if you see how all these things connect. So, there's nothing that's really new today. We're just connecting together things that we have previously learned. So the quiz that was scheduled today, we're going to put off because we're out of time. We won't have time to do a second one, so we might as well just do one at the end on all the energy stuff. So the next class will be kind of the review, then the quiz, and then the last class will be something else, and then we're done. We're done. That's it. You've almost made it. It's all coming together. I'm here for you if you need me. Please do not be afraid to ask for help. Good luck, and I will see you guys next time.